Kia ora koutou. Here are two differential equation questions from summer 2023. The first one was a request from Tom, so thanks for sending that in, Tom. Okay, so I'll just preview both of them and just see what you notice straight away. So we've got dy by dx is equal to y squared plus 4 here, and we've got a mixed up x and y thing in the denominator. X is positive, and we just have to solve the dE to get the value of x when y is equal to 2. In the second one, we've got a differential equation, but this time we have to obtain an expression for y in terms of x. So that means that in this one, we have to go the whole way through and get y blah, 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 and up here we just have to figure out what x is when y is 2. And then in the second question, we have to just look at what happens to y as x tends to infinity. Okay, so let's go back and do this first one. So pause the video and give it a go, and then I'll work through it. Okay, dy by dx is equal to y squared plus 4 over x times y plus 4, and x is strictly positive. So as usual, we separate the variables. I'll get all the y stuff here. And I'll get all the x stuff on the right-hand side, and we're going to integrate both sides with respect to y and with respect to x. So looking at the left-hand side first, let's just look at the denominator and see that here we've got y squared plus 4. So doing some reverse chain rule, in the numerator, I haven't got 2y here, but I've just about got 2y. So we're going to split this up into two parts, and hopefully you're recognizing that there's an inverse tan in this second bit here where we've got the 4 over y squared plus 4 here. So splitting that up into 2, we'll get y over y squared plus 4 over y squared plus 4 dy, and here we've got the natural log of x. Now, I could have put the plus c here, but I decided that I would plonk it on the left-hand side this time. You can do whatever you want with that. So my pattern for this integral here is that I've got just about f dash of x over f of x. Obviously, you don't need to write that down. That's just me just showing you to spot the pattern that we've seen over and over this year. So here we're going to have half times the natural log of y squared plus 4. I don't need absolute value signs there because we know that y squared is positive and y squared plus 4 is even more positive. The half is because when I differentiate this, I get 2y coming out, but I just want to have y here. Right, now the next bit will take a little bit more slowly, and if you can do this confidently without all these steps, then go for it. But it's pretty easy to make mistakes in here. So we're going to take out the 4, and I'll have 1 over, and I've got 4 plus y squared. Now, I don't want to have 4 plus y squared. I'm going to force in my pattern of 1 plus something squared. And just cleaning that up a bit more, you can see that here we've got 1 over 1 plus y on 2 squared dy is equal to the natural log of x. Also, we know that x is positive, so we can drop the absolute value signs there as well. Okay, so on the left-hand side, this is where I've got to. So this is going to be tan inverse of y on 2. By the chain rule, when I differentiate that, I'm going to get this here times 1/2. And I don't want that 1/2, so I have to undo it by multiplying by 2. And now we'll have plus c is equal to ln of x. Now, in the question, we were told that when y is equal to 2 root 3, x is equal to 4, 2 root 3 is equal to the square root of 12. So substituting in values, we get a half ln of y squared, so 12 plus 4 plus 2 tan inverse of root 3, right, so it's root 3 because it's half of 2 root 3, plus c is equal to the natural log of 4. Right, now here we've got the natural log of the square root of 16 using my level 2 NCEA log rules, plus 2. Now the angle whose tan is root 3 is pi on 3. So here the natural log of 16 can be subtracted from both sides, so that gives me c is equal to negative 2 pi on 3. Right, so let's clean all of that up and see where we've got to. Well, we have the natural log of x is equal to a half ln of y squared plus 4 plus 2 tan inverse of y on 2 minus 2 pi on 3. So the last part of the question required us to find x when y equals 2. So I didn't e to both sides here or anything, I just substituted values in. So what happens when y equals 2? The natural log of x is equal to a half ln of 8 plus 2 tan inverse of 1, which is nice and easy, minus 2 pi on 3. That gives me 1/2. I'm doing this as if it's an exact value question, I've just realised, because I'm so used to doing that. So the angle whose tan is 1 is pi on 4. So I get 3 over 2 ln of 2 plus, right, pi on 2. So 1/2 minus 2/3 is equal to negative 1/6. So it's going to be, it's not going to be plus, it's going to be minus pi on 6. So that's ln of x. So given that we're not asked for an exact value, you can go and bung that in your calculator if you want to. But if we're going to get an exact value for it, there's some good practice at working with exact values of e to the power of things here. So we've got x is equal to e to the ln 2 to the 3 over 2 times e to the negative pi on 6. That works out to be 2 to the 3 on 2 is 2 root 2 e to the negative pi on 6, which is 1.68 to 3 significant figures. Okay, but if you had been asked to do an exact value, then that's what you should have ended up with. Okay, that took too long. Sorry about that. I'm going to go a little bit faster on the next one. Similar thing in here, actually. So you're again going to have to be careful with rearranging to get your tan inverse coming out. And there's a nice second part to it where we have to say what happens to y as x tends to infinity. So pause the video, make sure you've copied the question down and give it a go. Here's my DE here, and we're told that when x is 1, y is equal to 0, and this time we have to get y is equal to blah, blah, blah. Okay, so dy by dx is equal to 4 plus 9y squared over e to the 2x plus 1. Separating the variables gives me this. I'm going to integrate both sides as usual. Here I'm again going to do my thing where I pull out the 4 to get 1 plus 9 over 4y squared dy, so that I'm setting myself up not to mess up my tan inverse integral. And here we've got a pretty easy integral on this side, so it's going to be e to the negative 2x minus 1, expanding that out. When I chain rule that, I'll get a -2. I don't want the -2, so we undo it like that, and we'll put our plus c on this side. So in here, what have I got here? Well, I've got 1/4 of 1 over 1 plus 3 over 2y squared dy is equal to my right-hand side. So that's going to give me 1/4 times tan inverse of 3 over 2y, but I have to undo my derivative of the inside function, so I need to times by 2/3. And now is about time to substitute in my x equals 1, y equals 0 point. So cleaning this up here, we get 1/6 tan inverse of 0 is equal to -1/2 e to the -2 minus 1 e to the -3 plus c. So tan inverse of 0 is a very easy 0. That gives me c is equal to 1 over 2 e to the -3, or 1 over 2 e cubed. Right, now we have to get an expression for y. So we've got to put it all back into where we've got to. Whoops, gosh, there's a lot of maths on that page. Just let's look at this question. Where are we? Yeah, so we need to rearrange this. Okay, we've got the value of our constant, and now we're getting y equals. Okay, so 1/6 tan inverse 3 over 2y is equal to -1/2 e, and so on, and we've got our constant in here now. Now I went quite slowly with this because I think it's really easy to muck things up. So first I times through by 6. And now I undid the tan. So this is the angle whose tan is 3 over 2y. So we get 3 over 2y is equal to tan of this. Giving me a final answer of y is equal to 2/3 of this. Now I just want to have time to do this last bit because it's, I think, a really nice last mark. We're asked what will happen as x goes to infinity. I'll just get rid of this muck over here. So when x goes to infinity, let's look at where it's sitting in the equation. Well, x is in here. So thinking about my graph of e to the x, that's e to the x, and we have e to the -2x. Right? So it's looking like this. So that's e to the -x. E to the -2x will be steeper, but the same kind of idea. So we know that as x goes to infinity, e to the -2x minus 1 will go to 0. And that gives me my answer, because that's the only place that we've got anything going on with x. So, why is my screen not moving? Huh? Okay. Okay, sorry about that. So as x goes to infinity, y tends to 2/3 of tan of 3 on e cubed. Okay, because the limit of this bit here is 0. Right, I'll do some vectors questions tomorrow from this paper, and if you've got any other requests for hard problems, just send them in. Thanks for watching.